All right, we're going to do 7A. 7A, there was a lot of problems that people left, and I don't know whether they just didn't get to them or they really had questions, but I'll go through them. Number 1 on 7A asked, distinguish between an outcome and an event. An outcome, like if I threw a die, flipped a coin 2 times, let's just say. So I could get a heads or a tail, and then a head or a tail, and a head or tail on the second one. So I could get 2 heads, a head tail, a tail head, or tail tail. There are 4 outcomes. An event might be getting 1 head, which is 2 outcomes put together. This outcome has 1 head and this one. So an event is 1 or more outcomes that fit into a group, like having 1 head or having 1 tail. Having 2 heads could be considered an event and an outcome. Okay? And it says, give an example where the same event can occur through 2 or more outcomes. And I just did. We can get the probability of a head. Getting a head once is an event that can happen 2 ways on this. That's number 1. Number 2. Number 2 says, what does it mean when we write the probability of event? So that means we want to find out how many ways that event can happen over probability that it number of ways it doesn't happen. And the probability of an event is always between 0 and 1. That's what they wanted you to get there. And why? Because it could either 100% chance or no chance or somewhere in between. Okay, 3. Briefly describe the differences between theoretical, relative frequency, and subjective. Theoretical probability is a situation where we know all the total, every possible outcome. We can count them up. If they're all equally likely, that's great. If they're not, that's okay. But we know all the outcomes, and we know what outcomes we desire. For instance, theoretical for rolling a 5 with 1 die, there's 1 outcome that would be success, rolling the 5 out of the 6 total outcomes. Now it doesn't mean that every time we roll it we get 1/6 of a 5. It means 1 out of 6 times we get a 5 theoretically. Will we actually get 1 out of every 6? Maybe, maybe not. Relative frequency is another way for saying the experimental or empirical, and that's just common examples of that might be sports stats. A good free throw basketball player good at free throws might make 80% of his shots, which means 8 out of 10, or might make 7 out of 10, or something like that. It's going on what their previous data says. And then subjective. Subjective is, I just think that that's going to happen at I think it's without any background or anything. I'm just coming up with, I suspect that there's a 30% chance that everybody will be in class tomorrow. Okay, something like that, where I'm kind of making it up, might have a little bit of an idea, but it's totally subjective. Okay, number 4. How is the probability of an event not occurring related to the probability that it does occur? The probability of it of the event occurring, let's say, is P of the event. the probability of it not occurring is 1 minus that. Probability of the event not happening, or the event's complement. 5. What is a probability distribution? Explain how to make a table of probability distribution. So I'll go back here to where number 1, where I flip a coin twice. And so I could have gotten out of that, the number of heads I could have gotten could have been none, or 1, or 2. And the probability of getting none is 1 of the 4 outcomes, so it's 1/4. The probability of getting 1 head is 1/2 of the 4, so that's 2/4 or 1/2. And the probability of getting 2 heads was just the top branch, which is 1 out of 4. And so and all my probabilities added up should equal 1. Okay? And 6. Explain the common usage of the term odds and its usage in gambling. Gambling, it's it's usually theoretical, and it's the number of ways it's against, so to lose over the number of ways to win. Okay? The probability of not being successful over the probability of being successful. That's the odds against. Odds for are just this upside down. So that's 1 through 6. Now we'll go on to 8. Does it make sense that the probability of my sister going to college is 3.7? 3.7 doesn't make sense because probability is somewhere between no chance and 100% chance. Probability is always between 0 and 1. Can't be 370% chance of her going to college. 3.7 doesn't make sense. Number 10. Because life is either there is life on Mars or there is not, the probability of life on Mars is 0.5. Because there are 2 outcomes, life and no life, doesn't mean that those 2 are equally likely, which would be indicated by a 0.5. There are 2 outcomes, but they may not be equally likely, and the probability is how likely is there life or not life. And since there's only 2 outcomes, that doesn't mean each one has to be equally likely. Number 20. 20 says, theoretical probability rolling a single dice and getting an odd number. Well, the dice has a 1 or a 2 or a 3 or a 4 or a 5 or a 6. The odd ones are 1, 3, and 5, so the probability of an odd is 3 out of 6, which is 1/2. 22. Drawing a black card from a standard deck of cards. Probability of a black. Well, in the standard deck of cards, there are 52 cards, and the number that are black, that's the spades and clubs, are half of them, which is 26. So the probability of getting a black is 1 out of 2, that's what this reduces to, or 0.5. 24. The randomly selecting 3-child family with exactly 2 girls. 3-child family could be a boy or girl for the first child. Second child could be a boy or girl. Or the third child could be boy or girl. So there is a total of 8 outcomes. 1 branch, 2, 3, 4, 5, 6, 7, 8. And how many of these branches have exactly 2 girls? That has no girls. This has 1 girl. This has 1 girl. This has 2 girls. There's one of them. This has 2 boys. This one has 2 girls. That one had 1 girl. This one has 2 girls, and this one has 3 girls. So the probability of having 2 girls happens 1, 2, 3 of the ways. Another way to look at it, the first child could have been a boy and then 2 girls, or it could have been a girl and then a boy and then a girl, or it could have been a girl, girl, and then a boy. Girl, girl, boy, boy, girl, boy, girl, girl. The boy could have been first, second, or third. And the other one's girls. 3/8 ways. That's 24. Next one is 26. Randomly selecting a person has a randomly selected person has a birthday in June, July, or August. Okay. If you pick a person, they could have it on any day of the year, so that makes 365 days possible. And how many days are there in June, July, or August? Wasn't that what it was? June, July, or August. June has 30 days, July has 31, and August has 31. So you would add those up, that's 92 out of 365. 27. 27. Sharing a birthday with another person when you both have birthdays in October. So there's going to be one of you has a single day in October, and the other one would have to have the same, and the chances are, since there's 31 days, and there's only one of them that would match. So it's 1 out of 31 of 31 days. If you both have birthdays in October, there's 1/31 chance that they both are the same. 28. A randomly selected person is born on a Wednesday. Well, there are 7 days possible, and only one of them is a Wednesday. Next one is 32. 32. We're supposed to now find relative frequency. 32. You toss a coin, 2 coins 100 times and get 0 heads, 23 times, 1 head, 51 times, and 2 heads 26 times. Do you have reason to suspect the coin is unfair? Well, from what we did on one earlier, we know that you can get head or tail, and then a head, tail, and so there's 1 out of the 4 for tail, so that should be about 0.25 in 100. And if this is 100 tosses, which it is, we should get no heads, 25 out of the 100 times, we got 23. That's pretty close. And one head happens 2/4 or half the time. 51 out of 100, pretty close. Two heads, we got 26. We're expecting 25 out of 100, pretty close. There's not enough here to say, it appears that there's not enough evidence here to say that the coin is unfair. That's 32. 33. No, 36 is the next one. 36. What is the probability of not tossing 3 tails with 3 fair coins? Well, the probability of tossing 3 tails is 1/2 chance on the first toss times 1/2 chance on the second times 1/2 chance on the third, which is 1/2 to the third, which is 1 to the third is 1, 2 to the third is 8, or in decimal that's 0.125. That's the probability of tossing 3 tails. So the probability of not tossing 3 tails is 7/8 or 0.875. 39. Probability distribution. The number of boys in a family with 3 children. So it could have been boy, boy, boy. I could do a tree diagram. I think I did already. But yes, I did. I'll pull that one back here. Number 24, I made the tree diagram. Probability for number of boys. So I could have no boys, 1 boy, 2 boy, or 3 boys. There's only one way to not get any boys. That'd be all girls out of the 8, 4, 5, 6, 7, 8 outcomes. To get 3 boys, there's 1 out of 8. And to get 2 boys, which means 1 girl, there's 1, 2, 3 ways, and there's 3 ways to get 1 boy. There's the probability distribution for getting 0, 1, 2, or 3 boys in a family of 3 children. 39. Next one is 42. 42. Number of girls in the family with 4 children. Okay, so 4, there's 16. You could get 0, 1 girl, 2 girls, 3 girls, 4 girls. So there's 1/16 chance of getting no girls. All of them are boys. There's 1 chance in 16 to get all girls and no boys. To get 1 girl, it would have to be either the first one, or the second one, or the third one, or the fourth one, which means there are 4 chances in 16. Same with if I got 3 girls, that means I had 1 boy. And the boy could have been the first one, second one, third one, or fourth one. So there's 4 ways to do that. And so without drawing a tree diagram, I know what this has to be, because these have to be add up to be 16. And I've got 1 plus 4 plus 4 plus 1, which is 10. So there's 6 more ways to get the 2. And I can count those. The first, I'll show you how to count that. The first 2 we're looking for, we're getting 2 boys or 2 girls, whichever way. So those 2 could be boys and these girls, or those 2 boys, that's 2, or those 2 boys, that's 3, 4, 5, 6. First 2, first and third, first and fourth, second and third, second and fourth, or third and fourth. Could be boys, and vice versa. Yeah, could be girls. So there's 6 ways that happens. That's 42. Next one is 44. 44. What is the let's see, odds. Flipping 2 fair coins and getting 2 tails. We talked about that. That's head, 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 tail, tail, head, tail, tail. And the odds for getting, flipping twos, and odds of getting 2 tails. Well, 2 tails. There is one way to get 2 tails. Odds is number of ways to get it over number of ways to not get it, which are 3 ways not to get tails. So the odds for getting 2 tails is 1/3. The odds against getting 2 tails is 3 to 1. 45. Rolling a fair dice and getting 5 or a 6. 6. So rolling a fair die, single die, sorry, forget this, a fair die. 1, 2, 3, 4, 5, or 6. And getting a 5 or 6, the odds for that, there's 2 ways to get it, and 4 ways not to get it. That's the odds for. And the odds against would be 4 to 2, which is 2 to 1 or 2. Odds against, odds for. Getting what you want, not getting what you want. Not getting what you want, getting what you want. Okay, 46. 46 says, flipping 2 fair coins and getting a head and a tail. Head and a tail happens 2 ways. 2 ways out of 4. But we want, if we're doing odds, we want to do, there's 2 ways to get it and 2 ways not to get it. So the odds for are 2 to 2 or 1, 1 to 1. And odds against are flip it over and it's still 2 to 2 or 1 to 1. 46. 48. 48. Odds on, which is against, you bet 5 are 5 to 4 and you bet $20. So you bet 20. If you win, you get your 20 back and you gain 5/4 of $20. And so 4 goes into 25 times 5 is 25. You gain 25 because you get your bet back and $25. That's 48. And now we'll go to 53. 53. Randomly meeting someone born between 2 p.m. and 3 p.m. Okay, so there are 24 hours in the day, and there's one of those hours, so there's a 1 in 24 chance of meeting somebody born between 2 and 3. Simple enough. 54. Randomly meeting somebody born in April or October. 365 days. April has 30, October has 31, so it's 61 out of 365. 57. Randomly selecting 3 child family with 3 girls. Well, we've seen there's only one way, and if you have 3 kids, it's 2 choices on the first one, boy or girl, times 2 for the second one, times 2, there's 8 outcomes. So having 3 girls is 1 in 8. 60. Waiting longer than 15 minutes when you arrive at a bus stop randomly that leaves promptly on the hour and half hour. Wait longer than 15 minutes. So here's the hour, and here's when the bus comes. The bus is there. The bus comes in the middle of the hour, at the end of the hour. And so if you come anywhere in here, you're going to wait. You'll miss this bus, and you'll have to wait more than 15 minutes. If you come in here, you're going to wait less than 15 minutes. If you come here, you're going to miss this bus, and you're going to have to wait 15 minutes, more than 15, and here's less. So half of the time you'll wait more than 15, and half of the time less than 15. So the probability is 1/2 that you'll have to wait more than 15 minutes for the bus. 62. Baseball player with a hitting average of 300 means 3 out of hits 3 out of 10 times. Will get a hit at his next at bat. 3/10, 0.3. That's it. Simple enough. And 66. Randomly meeting someone not born in May or June. So May is 31, June is 30, so that's 61. And we want not those, so we got 365 minus 61 out of the 365. That leaves 304 days that would be not in May or June out of 365. And finally, 80. You are supposed to, on 80, actually go to the internet and look up the plus and minus percentages for each blood type. A, B, and O, positive and negative. So I'm going to leave you to go online and look up what percentage of the population has AB positive, AB negative. That should be negative. B positive, B negative, AB positive, AB negative, O positive, no negative. They're not all equally likely. And that's it for 7A.